All right, welcome to The Explainer. Today we're going to unpack a concept that completely changed how we see the universe, the butterfly effect. It's this incredible idea that reveals there's a hidden layer of chaos kind of lurking just beneath the surface of our everyday world. So where does a story like this even begin? Well, it doesn't start with some grand, sweeping theory. Nope, it starts with a total accident. We're talking winter of 1961, when a simple shortcut ended up leading to one of the most profound discoveries of the entire 20th century. Okay, so picture this. Over at MIT, you've got this meteorologist, Edward Lorenz, and he's running this big, clunky computer simulation to try and model the weather. Now, he knew it was a super complex system, but he had this fundamental belief, right, that if you just had the right rules, the weather should be predictable. So one day, he wants to rerun part of his simulation. And to save a little bit of time, he takes a shortcut. He just re-enters one of the starting numbers from a printout. But here's the thing, he doesn't type in the full number. See, he rounded the number down to just 3 decimal places. The change was, it was minuscule. We're talking less than 0.1%. And in any normal, well-behaved system, this should have been a totally insignificant rounding error. It shouldn't have mattered at all. But when Lorenz came back an hour later, he was absolutely stunned. The new forecast was just dramatically different from the original. We're talking sunshine completely replaced by storms. He thought it had to be a computer bug, right? But it wasn't. He had accidentally discovered chaos. And just like that, this startling discovery gave birth to an entirely new field of science. It was one that would completely redefine our understanding of how the world works, and we call it chaos theory. So what Lorenz had stumbled upon was this. Many systems in nature, like the weather, aren't actually random. They're chaotic. What's the difference? Well, they follow strict fixed rules. But, and this is the crazy part, they're still fundamentally impossible to predict in the long run. And this right here, this is probably the most mind-bending insight of chaos theory. Let me say that again. Just because a system is deterministic, meaning it follows set rules, doesn't mean it's predictable. The future is technically set by those starting conditions, but since we can never ever know those conditions with perfect infinite precision, the long-term future is just unknowable. This idea just completely shattered the old dream of a clockwork universe. You know, that old Newtonian idea that if we just had enough information, if we knew the position and speed of every particle, we could calculate the future with perfect certainty. Well, chaos theory came along and proved that dream was, and always will be, impossible. Okay, so this is where it gets really interesting, because this powerful idea goes way beyond just weather forecasts. So back in its home turf, meteorology, the butterfly effect basically puts up a wall. It sets a hard limit on how far ahead we can accurately predict the weather. Turns out, it's about 2 weeks. This is what led to something called ensemble forecasting. It's pretty smart, actually. Meteorologists now run dozens of simulations, each with slightly different starting numbers, to see the whole range of possible futures. And then you look at biology, and you see how one single change can set off what's called a trophic cascade. The classic example is Yellowstone. When they brought wolves back, it wasn't just about the elk population. Get this. The wolves changed the behavior of the elk, which allowed plants along the rivers to grow back, which then stabilized the riverbanks so much that the rivers themselves literally changed their course, all from one species. And in economics, you bet, it shows how one tiny event can get amplified through all these feedback loops and trigger a massive financial crisis. Look at the 2010 flash crash. It's a perfect, terrifying example. A single large automated sell order kicked off a cascade that briefly wiped out nearly $1 trillion in value. Just like that. Okay, so let's bring all this down to a more personal level. But first, we really need to talk about that central image, right? The butterfly itself. Because we've got to bust a major myth here. It's such a powerful metaphor, isn't it? Lorenz first used it in a talk title back in 1972. But is it literally true? Like, for real? Can the tiny puff of air from an actual butterfly's wings snowball into a destructive tornado thousands of miles away? Well, the short answer from pretty much every scientist is no. The actual physical puff of air from a butterfly is just way too small. It dissipates into the air almost instantly and just doesn't have the juice to ever grow to that kind of scale. So, here's the crucial takeaway. The butterfly is a metaphor. It's a metaphor for that deep principle, sensitive dependence on initial conditions. It's all about the mathematical sensitivity inside the model, not a literal claim about insects and weather. But here's the really cool part. Once you get that it's a metaphor, it actually gives you this incredibly empowering way to look at the world. It tells you that, yeah, small actions can matter, that your choices, your little inputs into the system can have huge, unforeseen effects down the line. And you know what? That's not fatalism. That's a reason for hope. And believe it or not, the story doesn't end with our big, classical world of weather and ecosystems. Nope. Today, scientists are taking this exact same idea and exploring it at the smallest scales you can possibly imagine.
We're talking about the absolute cutting edge of physics right now. The big question is, does chaos also operate in the super weird, counterintuitive world of quantum mechanics? And if it does, what on earth does that even look like? Well, some incredible recent experiments have actually, for the first time ever, observed this quantum chaos as it unfolds. The best way to think about it is like dropping a single drop of ink into a swirling pool of water. Scientists can now actually measure how a tiny quantum change spreads out or scrambles through a whole system of connected particles until it's just completely mixed in.
And get this, to describe this whole process, they've come up with a totally fascinating new concept, scramblons. Now, these aren't actual particles you can hold. They're more of a way to describe the collective wave of chaos that carries and scrambles information through that quantum system.
So why should you care about any of this?
Well, because quantum computers, the next potential revolution in tech, are built on these very principles. And that means they are incredibly sensitive to the exact kinds of tiny errors that this quantum butterfly effect describes. If we're ever going to build quantum computers that actually work, we have to figure out how to tame this chaos. So let's end with this one last thought. The very same phenomenon that makes our weather impossible to predict past 2 weeks, that same idea might hold the secret to unlocking the next great leap in technology. Think about that. A journey that started with a simple rounding error on a 1960s computer is now leading us straight to the heart of reality itself.